Alright, what I'm looking at here is the difference between BH3 and R2BH. We're going to find out something kind of interesting. They both behave very similar, but they're not actually interchangeable. We're going to see BH2, or the BH3 is used when we want to do an anti-Markovnikov addition to an alkene. So what I'm going to do to make this anti-Markovnikov is I'm going to actually start with a alkene that has 2 carbons on one side, 2 hydrogens on the other. All right, so when we use BH3, we're going to have that added with THF. Think about the THF as just being a nice solvent that keeps it from actually reacting with itself. And after the first step with this, our alkene will be gone. It's going to break down that quick, and I'm going to actually rotate how this thing goes on because we see something kind of interesting. The BH3 goes on at this point, but it goes on with a H on one side and a BH2 on the other. Now, we're going to react that with our step where it takes some hydrogen peroxide and some base, OH negative, and all that does is rip off that BH2 and put an OH in its place. But the direct result is a syn addition of water, HOH. All right, the R2BH is only used with alkynes. So I'm going to use a similar one with a single methyl on one side, a triple bond, and a hydrogen on the other. Our first step on this will be a bulkier BH3. And we're going to get it bulkier by putting 2 carbon groups on there. Isopropyls work, but it doesn't really matter what the R's are. That's why we actually just put R and, to tell you there's something bigger on there than just a hydrogen. All right. This thing, we can think of it as doing something like this, but what it ultimately does, and I'll just do this in a 1-2 step thing, because the second step is the exact same stuff, hydrogen peroxide and OH. So really, fundamentally, the thing that's really different is that first species. And yet our first product this makes looks very similar to that thing up there. We're going to have a CH3 to a C that's now double bonded to that CH. And on the outside, we'd have an OH, and on the inside, we'd have an H. All right, see how similar these are? What's different about this one, though, this molecule is hardly ever stable. An alkene all, where the OH is right on that double bond, almost always rearranges through tautomerization, where this location gets that H, and we get a CH2 instead. And then it's single bonded to that still as a CH, but now is double bonded to O. So what we can view it as is this H kind of moves over and takes that bond with it, and we make a double bond there. All right, but ultimately, or summarize, I have an alkene with R groups, and I can just put H's everywhere else. If I do a 1-2 with BH3.THF followed by basic hydrogen peroxide, I will always get an anti-Markovnikov addition of H and OH, and it's a syn addition. If I change this to an alkyne, the similar reaction is still a 1-2, but now it's R2BH and THF, followed by the basic hydrogen peroxide. And we always get RCH2, CH, double bond to the O.